After transferring about 25 milliliters of stock solution into a beaker, use a 10 milliliter volumetric pipette to transfer about 5 milliliters of the solution into the beaker to a 25 milliliter volumetric flask. Note, it is important not to let solution into the bulb during the transfer process. After the solution is diluted in the volumetric flask, the new diluted solution is poured into an empty 100 milliliter beaker.
In order to dilute the solution, use the 10 milliliter volumetric pipette to transfer about 5 milliliters of the solution to a 25 milliliter volumetric flask. Then add 10 drops of ammonia and fill to the line with water, ensuring to fill to the bottom of the meniscus like with all measurements.
It is important to mix the dilution.
I know y'all are dying to know who's behind the camera, so here's my face reveal. Hey below!
Solution is the concentrated solution that you start with, and a dilution is when you add more solvent to make the solution less concentrated. The equation that relates these is M1 times V1 equals M2 times V2. M1 equals your initial concentration. V1 is the volume of the stock solution. M2 is your final concentration after you dilute, and V2 is the final volume after adding solvent. The amount of solute stays the same, you just spread it out in a larger volume, so the concentration goes down, but your moles don't change.
It is important to keep the workspace clean during and after the experiment. Clean glassware in the sink with soap and dispose of waste properly.
This is a flip through of my lab notebook that we use to keep our procedures in check.
First, take the mass of the hydrated copper sulfate and divide it by the molar mass of the compound to get to moles. Then divide the moles of the hydrated copper sulfate by 0.025 liters, the liters used in the dilution process, to calculate the molarity of the solution. It is important to convert from milliliters to liters for this calculation.